Hello, my dear students. How are you? Hope you are quite well. And today we are going to discuss two numerical problems. One problem from chemical kinetics and another problem from solution. Okay. So first of all, we are taking into consideration the numerical problem regarding chemical kinetics. So numerical problem number one. So here the problem says a first order reaction takes 40 minutes for 30% decomposition and calculate T half. T half means half life period. Okay, my dear student. So what is given here? A first order reaction. So first of all, we are going to discuss the first numerical problem on chemical kinetics. So the reaction is first order. So for first order reaction, so what is the rate law for the first order reaction? What is the rate law? What is the integrated rate law of the first order reaction? Mind it, integrated rate law. So for first order reaction, K means rate constant. K means rate constant. So K is given here as K is 2.303 for first order reaction by K into log A by A minus x. So what is A and what is A minus x? A is the initial concentration. A is the initial concentration of the reactant. This is the A. A is the initial concentration of the reactant. And what is A minus x? A minus x, that means this is the concentration of the reactant, at time t. This is the concentration of the reactant left at the time t. So let us say left, concentration of the reactant left at time t. Okay. So here in this case, what is the A and what is A minus x? So here initially no product is being formed. So at time t equals to 0, what is the A? A is the 100%, and at t equals to 40 minutes, what happens at 40 minutes? Because at 40 minutes 30% decomposition occurs. That means at t equals to 40 minutes, A minus x is 30% decomposition occurs. That means 30% of the reactant gone. 30% of the reaction 30% of the reactant has been consumed. So at t equals to 40, what percentage of the reactant left at t equals to 40 minutes is 100 minus 30, that means 70%. So what happened? Oh, sorry, here it is t. So K equals to 2.303 by t equals to, here what is the t? T is 40 minutes, and log, and what is the value of A? A is the 100% and A minus x is the 70%. So after calculating this, we get what is the value of K? The value of K gives 8.91 into 10 to the power minus 3 per minute. 10 to the power minus 3 per minute. Okay. So this is the value of K. And what is the unit of K? The unit of K is the minute inverse. The unit of K is the minute inverse. Why this is the minute inverse? Because if you look at the integrated rate equation, that is the K. So here the unit of k can be derived as follows. Here the log, the unit of this portion, the unit of the portion is null, because this is unitless. This is the ratio of the two same quantity, so this is unitless, and this is a pure number. So unit of k depends on the unit of t, and 1 upon unit of t, because t is in denominator. So what is the unit of t? The unit of t is minute. So unit of k will be minute inverse, 1 upon minute, that is minute inverse. So this is after rigorous calculation, it gives k equals to 8.91 into 10 to the power minus 3 minute inverse. So now we are to calculate the t half. So for first order reaction, for first order reaction, half life of the reaction given as 0.693 by k, and we already derived the value of k. This is 8.91 10 to the power minus 3, and the unit of k is minute inverse, so the unit of t half should be minute. So after calculating t half gives 77.78 minute. So this is our answer. T half equals to 77.78 minutes. We are not going through the detail of the calculation because it consumes time. So this is the final form of the T half. So T half is the 77.78 minutes. So my dear students, you are going through a very important numerical problems regarding chemical kinetics, and here we use the concept of first order rate equation. So here the two main equations are being used. One is integrated rate law of first order reaction and the half life period of the first order reaction. So I must request my dear students to please note down this, all these things I have written in the whiteboard, otherwise you all forget it. So now I am going to remove all this, and I am going to discuss the second equation here, second numerical problem here. So please write down the things by pausing the video. Okay, so I am going to remove this. I think you can write down in your copies by pausing the video. Okay, my dear student, please write down. So in our next part, we are going to discuss the numerical problem 2 regarding, this is the problem regarding solution. So here given, what will be the osmotic pressure of a 0.1 mole monobasic acid if its pH is 2 at 25 degrees centigrade. So first of all, you should know the formula of osmotic pressure. You should know the formula of osmotic pressure, and this is the monobasic acid. That means this monobasic acid, that means that as it is an acid, whether it is monobasic or dibasic, I am not going to this, but this is an acid. So as it is an acid, it must dissociate into the solution. Okay, so you cannot use the simplest form of osmotic pressure, rather than you are taking into consideration the Vant factor. Why you are taking, you should why you should take into the consideration of the Vant factor? Because here the solution is of an acidic solution, and as the acid is dissociative in nature, it dissociates when it comes into the water solution. So you must use the colligative property, the formula of all four colligative properties in its Vant factor form. You must take into consideration the Vant factor. Okay, so the osmotic pressure here, osmotic pressure pi should be ICRT. You are taking into consideration the I is the Vant factor. Vant factor, I is the Vant factor. Okay, so I am again telling my dear student, if you do have any queries, any doubts, you can please write down in the comment section. Okay, so that I can get your questions, I can get your queries. So this is the Vant factor. So how to calculate the Vant factor? So Vant of factor is nothing but I is the Vant of factor, that is the observed property, any property, observed property by theoretical property, theoretically calculated property. So observed property means what is happening in the actual form, what is happening in the real ground, and theoretical property means when you are not considering the real ground scenario, then the property is a theoretically calculated property, and this is the observed property. So observed property means you want to take into consideration all the realistic ground level scenario. Okay, so the monobasic acid we are taking into the HA. HA is the monobasic acid. This is the way to write a monobasic acid, because a monobasic acid, mono means one. Monobasic acid means one molecule of the monobasic acid gives one proton in its water solution. So this is HA is a monobasic acid. So when it dissociate, this is the monobasic acid. Mono means one. This is the monobasic acid. Chemistry is not a very difficult subject, but it is the subject of understanding. So this is the monobasic acid HA. So initially the concentration of monobasic acid C, and the concentration of H plus and A minus is 0. So at equilibrium, what happens? At equilibrium, it gives C alpha and it gives C alpha also. That means one molecule of HA gives one ion of H plus and one ion of A minus. So what is the percentage of what is the fraction of molecules of HA left? This is C, and it is C minus C alpha. This is not C minus C alpha minus C alpha, because one molecule of C gives two molecules of C alpha and C alpha. So one molecule of C is sufficient. That's why I subtract only one C alpha. Okay, so this is the, so at equilibrium, concentration of H plus ion, this is the concentration, is C alpha. So minus log of concentration of H plus ion means what? Means is pH, and the pH is the formula. pH is the formula. What is the formula? pH is minus log of concentration of H plus ion. Okay, the pH is given here 2 at 25 degrees centigrade. T is 25 plus 273, that means 298 Kelvin. So pH 2, that means concentration of H plus ion is 10 to the power minus 2, and this is nothing but C alpha. So C alpha is 10 to the power minus 2. And what is the value of C? And initial concentration of the monobasic acid is 0.1 molar. So what is the Vant factor? What is the Vant factor? Vant factor is the observed property, that is the observed we what property we are going to consider? We are going to consider the property of concentration. So observed concentration at equilibrium. Observed concentration as equilibrium is the C minus C alpha, that is the concentration of HA plus the concentration of H plus, that is C alpha, and that is the concentration of A minus, that is also the C alpha. So this C alpha cancel, is only C plus C alpha, 1 plus alpha. And what will be the concentration if no dissociation is occurred? Then it is the theoretically calculated property. If no dissociation is occurred, then the concentration will be the whole concentration of the monobasic acid. So theoretically calculated property, that is theoretically calculated concentration, will be C, and the observed concentration at equilibrium will be C into 1 plus alpha. So what happened here? So it gives 1 plus alpha. So I is 1 plus alpha. Okay, my dear student. Now what will be the I, or what will be the alpha here? So the alpha, we get C alpha, 10 to the power minus 2. So alpha is 10 to the power minus 2 by 0.1, because the C value of C is 0.1, concentration of the monobasic acid is 0.1 mole, that means 10 to the power minus 1, that is 0.1. So I is, Vant factor I is 1 plus alpha, that means 1 plus 0.1, that means 1.1. So we got the value of I. Now pi, because we have to calculate osmotic pressure, so I equals to ICRT, that means I, value of I 1 minus 1.1, value of C is 0.1, and value of R in terms of moles per, in terms of liter atmosphere, this is 0.082, and value of T is 298. So what will be the unit of pi? Because we use the R, value of R in liter atmosphere, so the unit of pi will be atmosphere, because the unit of pressure is atmosphere. Why it is atmosphere? Because we use here the unit of R as liter atmosphere, so that means it is atmosphere, and it is mole per liter. So it gives 2.69 atmosphere. 2.69 atmosphere. For your simplicity, this is a simple calculation. I am not going to into the details. I am just going to show how this unit comes here, pi. So what is the pi? Pi is I. I nothing is but a number. So this is unitless. So C, what is the unit of C? C is mole per liter, mole liter inverse. And what is the unit of R here? Here we take the R in liter atmosphere, so it is liter atmosphere per mole per Kelvin, this is liter atmosphere. And what is the unit of T? T is the unit of Kelvin, so Kelvin inverse cancel, liter inverse cancel, okay, mole inverse cancel, so only atmosphere sustained. So here the answer, the osmotic pressure will be 2.69 atmosphere. So my dear students, I hope you all learn something out of this class, and I hope you will enjoy this class, and we will meet again. Please do subscribe my channel, and you do have any queries, any doubts, you can write down in the comment section. So till then, goodbye, meet you in the next class.